Hi, my name is Joy, and we'll be doing the hands-on experiment that explains about the lung activities. We'll be doing this with my partner called Benny. And first, I would like to give a brief introduction about the structure of the pleura and some of its functions. So the pleura is found within the respiratory system, and it mostly surrounds the lungs. There's two layers to the pleura. The first layer is the parietal layer, which is found on the outside. It lines the chest wall and also near the diaphragm. And then the inner layer is the visceral layer, which lines inside the lungs. So think about your lungs as like a book. So the first sheet that you would open up would be your parietal layer. Then the inner one is the visceral layer. And in between these layers is the pleural cavity, and it contains a fluid known as the pleural fluid, which helps the two layers slide over each other. Think about it as like your hands with lotion or oil. So the oil would act as the pleural fluid, and it would make the two layers slide over each other during breathing. This prevents friction. It would be very painful if we did not have, it would be painful to breathe if we did not have the pleural fluid. And then the visceral layer also is very well equipped. It's smooth and slippery, so that when it slides over the parietal layer, it doesn't also cause friction, and this way also the lungs are able to expand and take in as much air when we're breathing in. And then another thing to know is that the visceral pleura would also be known as the pulmonary pleura. Yes. The next thing is to know the pressure relationships that are found in the thoracic cavity. So we start with inhalation or inspiration. When we breathe in, the volume increases. So think about a bottle, a 2-liter bottle, and you have two of them. So not two, well, let's say you have one 2-liter and another 1-liter. So when you take in an amount of gas and put it in the 2-liter, and the same amount of gas you put it in the 1-liter, it would freely move in the 2-liter because it has much more space than the 1-liter. So this is what happens during breathing in. When we breathe in, our lungs expand and we are able to take in more air. Therefore, with the volume increase of air, there's a decrease in pressure. That's because of the space too. But when we breathe out, our lungs shrivel up. They become, not shrivel up really, but they become smaller in size. And thus the volume decreases, but pressure increases. This is an inversely proportional relationship between pressure in the thoracic cavity and volume. And then also in relation to atmospheric pressure and the pressure in the thoracic cavity, atmospheric pressure is, first of all, atmospheric pressure is the pressure that is exerted by gases or air on a surface. So when the atmospheric pressure is at 760 mmHg, which is usually the normal, the pressure within our lungs should be the same, about the same pressure. But in the thoracic cavity, we think of 3 types of pressure. So we have the atmospheric pressure, we have the intra-alveolar pressure, which is also the intrapulmonary pressure, and we have the intrapleural pressure. So intrapulmonary pressure is pressure found within the alveolar, and the intrapleural pressure is the one that's found within the pleural cavity. So the pleural cavity pressure is usually a little bit on the negative side. That I say negative as in it's usually a little lower than 760 mmHg. This is to keep the lungs from deflating. But the one in the alveolar, which is the intrapulmonary pressure, is the same as the atmospheric pressure, which is 760 mmHg, about that value. And when we say the pressure in the thoracic cavity is negative, that means it's lower than the atmospheric pressure. When we say it's positive, that means it's higher than the atmospheric pressure. And when we say it's at 0, that means it's the same with the atmospheric pressure. Yes, that's the introduction.
This is the respiratory system project. These balloons represent the lungs and the straws represent the air that are transferring into the lungs. So this is the outer balloon or the pleural cavity being inflated. Now she's blowing the inner lungs. And this is easier because the pleural cavity was already... Now she'll be blowing the inner balloon, which is the inner lungs, while the outer balloon, which is the pleural cavity, is collapsed. This is much difficult to blow because there's no space for the inner balloon to inflate.
So I'm going to talk about the real life applications of what we've just done with this experiment and regarding to the introduction that we've done. And in the real life world, it's very important to know how respiration goes. And because especially those of us who want to venture into the health field, those are pointers that you should know immediately when you see a person. So like when you see a person having chest pains and a hard time breathing, your mind should originally think that something is not right with the lungs. So the first disease that a lot of us know is pneumothorax, also known as the collapsed lung. This happens when the pleural cavity, the one that contains the pleural fluid, is filled with air, and this reduces, like when you're breathing in, this reduces the capacity of your lung to expand. So if this part, let's say this is like the pleural cavity, it's filled and it's not able to move, and this is your lungs, the only place it can move is just this, instead of like taking in the whole volume of air that it needs to take in. So when this happens, of course, someone is not able to breathe in properly, not enough oxygen is coming into the body, and symptoms of this condition is chest pains, shortness of breath. Yes. If you wish to treat this condition, think of relieving the pleural cavity of the air that is filled with. So the first thing that doctors, of course, recommend when they see this condition is to observe the patient. In some cases, it's not so severe, but in cases that it's severe, the pressure will have to be equalized in the lung, and this can be done through needle aspiration, chest tube insertion. When you see someone with the chest tube insertions, and in some cases it would have to be surgical. And then the other condition is atelectasis, which occurs when a lobe of a lung collapses, whether it's partial or it's completely. And so in this condition, you see the alveoli deflating, they shrivel up, and this is because of unequalized pressure in the lungs. So there's also a case of obstructive atelectasis, and this happens when we breathe in a foreign body that blocks our passageway. That could be the bronchus or the bronchioles. And to relieve that, basically you'd have to just take out the foreign body. Hopefully it hasn't gone too far. It can be sucked up from the nose, and if it has gone too far, then surgery would be needed. In other cases where it's a case of unequalized pressure in the thoracic cavity, of course, this might need, again, tube insertion, and also surgical or non-surgical procedures. So, yeah. And another condition that, well, disease that we mostly are familiar with is mesothelioma, which of course is cancer found within the lungs. And the mesothelioma affects the mesothelial cells that make up the two layers of the pleura, which is the visceral and the parietal layer. So yeah, so far that's what I've learned. I have learned to apply a lot, understanding the lungs. I've learned to apply a lot during breathing in and out. Even think about when you're doing your exercises, you'll know how to condition yourself more. And even, well, yeah, I mean, basically, it's good knowledge for you to know. So, yeah, thank you.